Hello, it's Dr. Churchill, returning back for Astronomy 308 into the final frontier. And we are now in the second phase or second part of the class where we're going to enter into discussions about the space race. And as you know, we've completed about 500 years of human exploration that was really based upon exploration over the seas. And we talked about how that developed into, global economies and nationalism, imperialism, colonialism, and all of the things that went along with the consequences of human expansion in this regard. And so, this class really is titled Into the Final Frontier, which is more about what we consider to be space. So now we're entering the next stage of exploration, which is, in a sense, we've explored the planet, and there's some work left to do there, but we've explored the planet and filled up a lot of the ecological niches of the planet. And now there is a new ocean, the ocean of space. And so we're going to spend some time in the class, another third of the course, if you will, talking about what has taken place as far as human beings moving out into space to the present day. And then we're going to have the last third of the class, we're going to talk about the future as well. Part two of the class really covers from the beginning of the space race and the onset of rocketry and the Cold War, which became transmuted into the space race as part of that struggle and that conflict. And then we're going to talk about the space shuttle era, the Skylab era, or what we might call the era of space stations, because the Russians had quite a space station presence in the Earth orbit. And I'm going to talk about the Chinese and how they've been reaching out mostly, and then end with what's going on with a lot of the other nations in terms of nationalized space programs. Of course, the big crowning achievement of the space race was the fact that 12 astronauts walked on the moon, and 24 astronauts traveled to the moon. And so these are the only people that have gone beyond low Earth orbit, which is only between, say, 250 and 500 miles above the surface of the planet. And that's not very far. I mean, you can drive that distance in a day or a part of a day. So it's not really that far of a distance when you think about it. But the moon's 238,000 miles away and almost 250,000 miles away. And from there, we've learned you can put your thumb out and block the entire Earth, just like you can block the entire moon with your thumb. And this has got to be a very different sensation. And I guess the thing about Apollo is it's the only human exploration off planet that involved a destination. And what we're seeing now, and is going to happen in the near future, is that more of our space exploration is going to be destination targeted. It's going to be less about going into orbit and doing things and more destination targeted. However, when it comes to the commercialization of space for tourism, that will be more Earth orbit oriented, and then we'll advance probably to the point of having flybys of the moon, what you call a figure eight free return trajectory around the moon. That would be a fantastic experience. Maybe orbiting the moon, and then eventually, when we establish bases on the moon, perhaps even having visits to the moon from a tourism point of view. But that's my guess on where it will all go. But nonetheless, I'd like to talk today about the development of early rocketry. And we're going to go all the way back to the 1850s and push ourselves forward into the 20th century and get somewhat into the 1900s. And today's lecture could really be titled more of like, science fiction begets science pioneers, or science fiction begets rocket pioneers, okay? And so I want today to make a connection between how science fiction becomes science fact, and then also talk about a small group of rocket pioneers who really set the foundation for why we were able to go to the moon and why we're able to do space today. You know, who were the first people to really put their brains into this problem? So what I'm going to do here is go ahead and share my slide. And I hope you can see this. And I know my cursor is not very big, but hopefully you can follow it. So we're going to start out just introducing to you, you know, the talking heads pictures, or the mugshots, if you will, of 5 very famous rocket pioneers. Okay. The thing about rocketry is it is a breakthrough technology. And as you know, we have always said that breakthrough technology is required to make the next step. You know, there's 2 steps. One is it has to be visioned by a person, and then that spread to other people. And then there has to be the breakthrough technology to allow it. And usually the ideas come before the technology. And in this case with rocketry, that is true as well. What I'd like to say in terms of science is that in Isaac Newton, we had our first physicist who was able to formulate mathematically laws of motion. You know, how does an object move through space and time, and how do forces acting on that object force it to move in different directions, to accelerate, speed up, or to change its direction. All of these equations were critical for understanding, you know, how to envision moving something through space. And the other thing about that was he came up with his theory of gravitation. And so the force that is acting on a rocket ship while it's in orbit, or while it's transiting from the Earth to the moon, for example, is the force of gravity. And so you have to understand that force that's acting on the rocket, because that's what, or a spaceship that's not in the process of thrusting itself. The force of gravity is what is pulling or pushing. Well, gravity doesn't push. The force of gravity is what's acting on the drifting space capsule or rocket. And this can accelerate it by picking its speed up or having it change direction. So all of that was critical to understand. Not only did Newton do those 2 amazing things which transformed humanity, but Newton also invented, or co-invented, because there's another individual in Germany who co-invented this type of mathematics I'm going to speak of, called calculus. So Leibniz in Germany and Newton, who got most of the credit, they sort of created this mathematics called calculus. And calculus is a very beautiful shorthand set of mathematics that allows you to describe very accurately how forces act on objects such as rockets. So you have all the ingredients put together here, right in this one human lifetime of Isaac Newton. All the laws of motion, forces acting on objects, how they move through space-time based upon those forces, the force of gravity itself and how you describe that, how it acts on objects, and then the mathematical tools to actually make the calculations, mathematical tools being calculus. All that had to happen, okay? And that is, in a sense, a knowledge breakthrough. That information even affected science writers, science fiction writers, as we'll show. But these rocket pioneers I'm showing here, they had to understand all of that information, what I'll call the Newtonian physics of rockets and forces and the mathematics. So these are very intelligent people. Not all of them are schooled in school. Some of them are self-taught, actually. And they embraced this dream that most of them learned by reading science fiction. And then they took the science of Newton, and they took the science fiction dreams of science fiction writers, and and they put them together and really worked toward changing humanity by building the breakthrough technology required to fulfill those science fiction predictions, I'll call them predictions, and also fulfill the breakthrough technology engineering. Okay, so of the three on the left here, you see my cursor is moving now. We're going to start with the true father of rocketry, Constantine Zio Koski. And he lived in Russia, and then of course he lived through the Soviet Revolution in 1917. But he lived in a very rural area of Russia and was very poor and self-taught. And he basically is considered the father of rocketry because he truly invented almost every aspect of spaceflight on his own in isolation in the backcountry of what is now Russia, then the Soviet Union, which is now Russia. Okay. He has a very famous quote. The earth is the cradle of humanity, but one cannot live in the cradle forever. And I think this is a quote that I'd like to see everybody in the world embrace in terms of the fact that we need to continue to grow and we need to continue to explore in order to basically learn about what the universe is like. Second here is Dr. Robert Goddard, and he's an American, lived from 1882 to 1945, so he died at the very end of World War II. We're going to see that he's credited with reproducing a lot on his own many of the thoughts of Constantine Zio Koski. And not only that, but putting them into practice. See, Zio Koski was a theorist. He did some experimentation, but he really didn't get off the ground building a rocket. Goddard built rockets, and he built the first liquid propelled rocket and flew it. And so he's very famous for that. And then we have Herman Oberth, who is from the Prussian area of Germany. And he was also very mathematically inclined. He did a lot of experimentation with rockets as well, and built some small rockets, but even though he lived all the way through the 20th century, most of it till 1989, he wasn't necessarily a major rocket builder, okay? Later in the next series of slides, lecture 2.1b, we will talk about these two gentlemen, Werner Von Braun, 1912 to 1977, who is known for building the rockets that took humans to the moon, amongst other things. And somebody that I would guess that Werner Von Braun is a name that most people have heard before. He's almost a household name in terms of what he's done for this country and his fame for what he did for Nazi Germany. But fewer people have probably been made aware of Sergey Korolov. And Sergey Korolov is another young man. He lived from 1907 to 66, so not a long life, but in that short life, he accomplished 10 human lifetimes worth of work. And he really is credited with starting the space race, building the first intercontinental ballistic missile, and putting the first satellite up into space. He really got the ball rolling. He was a hard-working, hard-driving, and intelligent, passionate, and dreaming young man. Okay. Now, before these rocket pioneers were able to really get off the ground, figuratively and literally, almost all of them were avid science fiction readers. And so I want to introduce to you one of the science fiction writers that really influenced these early pioneers, and that was Jules Verne. And Jules Verne lived from 1928 to 1905, so you can see where he lived in the timeline of those rocket pioneers, which is to say that he was an old man when most of them were born, and he had written many of his books. And so as children, the rocket pioneers had read these very famous science fiction books. One of the books he wrote was 20,000 Leagues Under the Sea. So it was always about adventure and exploration. And this one, that book was about going under the sea. He wrote from the Earth to the moon. That was about actually flying to the moon. And he also wrote a lot of aircraft type of science fiction. So he was a great visionary in an age when all of this was just in your mind and was a dream, okay? So in the sense that we watch Star Trek today, and they're zooming through the galaxy with warp drive, flying from star system to star system, you know, that is as far away from us today as, say, going to the moon was from Jules Verne back in those days. You know, yes, the equations of Newton were all existed, and actually Verne was pretty fluent in some of those equations and did a lot of calculations to make sure that what he was saying actually made physical sense, which is one of the things that makes great science fiction writers. Now, the thing is that the idea of building a rocket and sending it to the moon was so beyond the technology of the days when Verne was having these visions and writing these things down, that it's truly very much like Gene Roddenberry's Star Trek. You know, it's at least 100 years before its time. I hope it's only 100 years before Star Trek becomes reality. The most famous one with regard to the rocket pioneers and with regard to the space race is Jules Verne's From the Earth to the Moon. This is a story of a gun club that builds a huge space gun, and the rocket ship is kind of like a long extended bullet. And they basically put 3 people into this rocket and they fire it to the moon. And the force of the acceleration is supposed to be damped down by water. So he's thought about all of these things. Jules Verne even computed the energy and velocity requirements quite accurately as far as sending that projectile in the right direction and at the right velocity to escape the Earth's gravity and then be captured by the moon. So it turns out that we know that the astronauts would not have survived the initial launch. That's fine. But this is a very amazing story. It influenced people dramatically. And in fact, when the Apollo 11 astronauts named their spacecraft, they named it the Columbia. The lander that went down to the moon was called the Eagle, but the spacecraft that orbited around the moon, the command module, if you will, was called the Columbia. And of course, that was a throwback to the Columbiad, which was the name of Jules Verne's spacecraft. Now, you've probably heard of the HBO series From the Earth to the Moon. That HBO series is produced by and then hosted by Tom Hanks. And that series is actually based upon many of the chapters in Andrew Chaikin's book, A Man on the Moon. And as you know, Andrew Chaikin, that book, A Man on the Moon, is one we're going to read some chapters out of. And Andrew Chaikin himself is going to be our next distinguished guest speaker. So we're all looking forward to seeing what Andrew has to say about science fiction and how it influenced him and why he wrote about going to the moon. And I just wanted to let you know that the HBO series named itself not after the book, but after Jules Verne's book. I mean, not after Andrew Chaikin's book, but after Jules Verne's book. This is my last slide on science fiction. I just really want to make the point that these types of individuals have written things that probably some fraction will become science reality. And in fact, I am having you watch 2 supplementary videos associated with this lecture. The first one's called Science Fiction Becomes Science Fact. And goes through a list of the predictions made by many of these people I'm talking about and others, where they made predictions where science fiction that they wrote has become science fact. And in fact, you'll find out that some of them made many predictions that we take for granted today that we use every day, including what we are doing here, where I am speaking into my computer and communicating to you. You will see that Arthur C. Clarke, there's a clip of him in either that movie or the other video I'm having you watch called The Evolution of Science Fiction. I can't remember which one it is, but they show him talking and he basically predicts exactly what we're doing during COVID as far as remote working goes and how we use the internet. Okay, so the other thing that's not in those movies, which I want you to realize, is if you watch the Star Trek original series, you'll see that the little discs that they use, the way they communicate with their communicators, so much of Gene Roddenberry's technology actually exists today. The laptop, desktop computers they had, and then of course in the next generation with the laptops and the pads, it's really spectacular how these predictions come true. Anyway, three major science writers are Isaac Asimov, who is very famous. Maybe you've seen Will Smith in the book or the movie I, Robot. That's based upon his book I, Robot. It's about artificial intelligence basically trying to take over humanity. Really kind of a fun movie. And he has this foundation trilogy, which is based upon these civilizations that exist in the galaxy. He was an amazing human being. He also wrote a lot of popular books about physics, popularizing physics. And he was a biology professor at, I think, Boston University. And they say he could type 90 words a minute and he would never go back and fix his corrections. He would just hand it to the publisher and it was basically perfect. He said that if he was told to make revisions by the editor, that he just wouldn't publish the book because he was too busy writing a new book and he didn't want to be bothered. It wasn't worth it. So he was just that kind of mind. I can't even imagine that. Robert Heinlein. Robert Heinlein is most famous for a book called A Stranger in a Strange Land, which is about a Martian who comes down to Earth and he tries to understand Earthlings. He coined the word grok, if you've ever heard of that. It just means to try to understand and be one with an idea. He is also very famous for writing books about basically highly long-lived people that would exist for thousands and thousands of years of lifetime. So he was able to write plots that had long arcs like that. Okay, he was very much into the immortality issues and social issues. Arthur C. Clarke is really probably our more true futurists. Okay. He wrote about stellar civilizations. Like I said, he predicted iPads, global communication satellites, the internet. Okay, so he's most famous for writing 2001: A Space Odyssey. And as you can see from my background today, I'm giving a throw out to Arthur C. Clarke because this is a scene from the movie. And as you can see, it's very similar to the picture on his book here. He's also very famous for The View from Serendip. I'm not going to tell you about what all these books are about, but if you're interested in seeing what these people's vision were all the way through the early 1900s into the, I'd say the first half of the second half of the third quartile, if you will, of that century, 20th century, these people are basically your go-to people. Now, why the big deal about science fiction? We're going to make the transition now from science fiction to science fact. And so I wanted to show this cartoon, which I love on so many levels, but I'm also embarrassed by the fact that it's so stereotypical, about sort of the nagging wife kind of thing. So I wish it didn't do that, because I just wish that this message could be sent without that sort of social commentary, interlaced into it. But I love this idea of this dreaming individual living in a world where everybody else is sort of like, what's wrong with you? Get your head out of the clouds. Can you just let go of that science fiction gobbledygook, and start dealing with reality? Of course, we all know the joke here. Okay. And today people are putting things on the drawing board, the equivalent of the cave wall. And, for example, we'll talk about later in the third part of the class, warp drive, what people are trying to do to build warp drive. These are people that some other people think they're dreamers and schemers, that they, get real. Don't sit down and play with mathematical equations about warp drive. Because it's never going to happen, et cetera, et cetera. Why don't you put your talents to work on Wall Street? But in the end, it's the inventions of breakthrough technologies like, the wheel and putting a horse in front of it that completely changed the ability of humanity to go on and do other things that it never could have thought of doing before. Okay. This is the only mathematical equation you're going to see probably all semester, unless I want to, demonstrate to you how complex some of this math can get. But we're not getting into a part of the class where all of a sudden you're going to be seeing a lot of math equations. That's just not going to be happening. So here's Zio Koski, and just to give you a little background on him, he was very ill as a child. I think he had something like scarlet fever, and he lost his hearing significantly. And that isolated him. And you'll see the same thing through history, that these children that somehow are isolated from the world, they withdraw into their dreams and work hard at making them come true. And so this is part of the story of Ziacosi as a human being. He then became a school teacher after becoming self-taught, and spent a lot of his time cogitating about space travel and dreaming about humanity reaching for the stars. And when I say dreaming about humanity reaching for the stars, let me tell you, we are not talking about sort of like parking in Earth orbit for the next 50 years like we've been doing, but going out and exploring the galaxy. Okay, we'll talk about that in a minute. Because of his work, he's really known as the father of rocketry. In China, there's an individual who's known as the king of rocketry, but the true father of rocketry, in the sense that, Prince Henry is the father of continuous exploration. Ziacosi is the father of rocketry. All right. Now, when he was young, he used some of those equations I was telling you about that Isaac Newton had planted the foundation for, and he worked through them, and he came up with this simple equation. It's called the rocket equation, and it's very simple. This is what it says. You start out your rocket on the launch pad with some mass, total mass, m sub 0, meaning at the beginning of the mission is 0 times 0. And that mass includes all the fuel, and it includes the mass of the rocket itself, all of the hardware. And then you are going to ignite that rocket, and the fuel is going to come out of the bottom with some exit velocity. That's what this term here is, V sub E. So that's your exit velocity of your fuel, okay? Now, as you are shooting burnt fuel out of the back of the rocket, you are losing mass, total mass of the rocket, because some of the fuel is being burnt up and then expelled from the rocket. So the mass of the rocket is getting lighter with time. That's what this is. As time goes by, this would be the mass of the rocket, the hardware plus as time goes by, less and less mass in the fuel. So this number is getting smaller with time. This is just the initial mass. This is called a natural log. I don't want you to worry about that, but you calculate this ratio as a function of time. This is the velocity at which the fuel is leaving. This was your initial velocity at time equals 0, which of course, if you started on the launch pad, that was 0. And this is your velocity with time. So there you have it. He basically was able to say, I can tell you how the speed of that rocket's going to pick up with time. You give me after 10 seconds, after 20 seconds, after a minute and a half, after 3 hours, I can tell you how fast that rocket's going to be moving, assuming that the fuel is coming out of the exhaust at a certain velocity out of the back of the rocket. That's it. It's so extremely simple. And yet this was the key to understanding how to make motion. Now, what you'll see in this, what you won't see in this equation is anything like atmospheric drag or atmospheric pressure or all these things that have to do with the atmosphere. And that's beautiful because that tells you it works in a vacuum. This equation works in the vacuum of space. So if you're in a rocket and you ignite the engines, okay, you got your clock, it's set at 0, you got some total mass in your rocket with your fuel in your rocket, and you ignite the engine, then the fuel goes out the back, the burnt fuel goes out the back at this velocity, V sub E, then this is going to tell you how fast you can go. And it's a reaction. It's an opposite and equal reaction is the physics behind it. But using that physics, he was able to show that you could actually change a rocket's speed in the vacuum of space. Now, a lot of people didn't believe that a rocket would work in the vacuum of space because they thought that you were actually pushing on, that exhaust was pushing on the atmosphere. And then when you got outside of the atmosphere, it would have nothing to push on. But they missed the physics entirely. Ziacosi didn't. He envisioned it properly and invented this equation that is the first equation really to show that rockets indeed can function in space. And that is one of its major significances. I just want to note that he was a prolific and creative mind, that he has written several scientific papers throughout his lifetime, many of them envisioning the same things that Werner Von Braun was famous for envisioning in the 1950s, just before the space race really kicked in. So he was a very, very early pioneer in these ideas. I just wanted to demonstrate that he was a prolific thinker and writer. And this is a nice scientific paper on the design of rockets right here. Now, let's just talk about how prolific he was. In 1926, okay, this is between the two world wars, airplanes are just really getting in on their own. I mean, in 1918 was when planes were really being used in World War I for the first time to fight each other in the sky, to drop bombs, to do reconnaissance. And the plane was very, very new. It was only, say, in 1926, it was only about 23 years since the very first little airplane kind of flew on the beach at Kitty Hawk. Certainly no rockets had been built in Russia. We're going to find out that 1926 is the years that Robert Goddard flew his first little rocket about for 80 seconds, okay? Now, I want you to listen to this quote of Ziacoski's, and I'm going to read here at the top. And I want you to understand something about this. It's not a statement of maybe this will happen or maybe that'll happen or it could be. These are declarative statements. This man is confident these things will happen. And he is talking about things that go well beyond just sort of going into space or going to the moon. All right, let's look at this quote. Men are weak now, and yet they transform the Earth's surface. In millions of years, their might will increase to the extent that they will change the surface of the Earth, its oceans, the atmosphere, and themselves. Can you say genetic engineering, anybody? Or the technology of CRISPR, where we can go in and cut out segments of genes and replace them with others? They will control the climate and the solar system, just as they control the Earth. They will, these are declarative, travel beyond the limits of our planetary system. They will reach other suns and use their fresh energy instead of the energy of their dying luminary. Now, as an astrophysicist, I don't know where he got the idea that the sun was going to die, because in 1926, we really didn't understand what made the stars shine, and let alone knew that stars aged and died. So he clearly was up on the cutting edge ideas that may not even have made it into the science mainstream yet. And I don't know how he did that as somebody who was living pretty much in the rural areas of Russia. So in 1926, he wrote this plan for space exploration. And this is a 16-step recipe, if you will, for human expansion into space. And I just want to read these to you. And the ones I've marked in green are ones that we have already accomplished, okay? 1, creation of rocket airplanes with wings, check. Progressive increasing the speed and altitude of these planes, check. Production of real rockets without wings, check. The ability to land on the surface of the sea, splashdown, check. Reaching escape velocity and the first flight into Earth orbit, happened in 1957, check. A lengthening of rocket flight times in space. Some astronauts have actually been in space for over a year at a time, so check. Okay, use of plants to make an artificial atmosphere in spaceships. Definitely a lot of experimentation there, haven't succeeded yet. Using pressurized spacesuits for activity outside the spaceships, what we call an EVA, for extravehicular activity, check. Making orbiting greenhouses for plants, fantastic idea, still working on it. Constructing large orbital habitats around the Earth, like the International Space Station or Skylab or Salyut 7, the Mir, all these space stations that we've had. Check. Using solar radiation to grow food for transport throughout the solar system, working on it. Colonization of the asteroid belt, certainly is going to happen. Now we're getting into the things where obviously these are a future arc. 13, colonization of the entire solar system and then beyond. 14, achievement of individual and social perfection. Well, that's kind of part of the theme of the class, and also an ideal that will probably never be achieved. But are we going to, as we go out into space, have this unifying effect on us, which Frank White, I guess, would say is a part of the overview effect and a downstream result or consequence of experiencing the overview effect on a human-wide scale. 15, overcrowding of the solar system and the colonization of the Milky Way galaxy. We're going to need some breakthrough technology to make that happen. And then the sun begins to die and the people remaining in the solar system will have to move off to other solar systems. And you know what? I think that everything that Zio Koski wrote down here, if humanity doesn't kill itself or somehow become extinct from a natural disaster, global disaster, that every one of these bullet points, all 16 of them, will come true. It's just in our nature to continue doing so. But what I just want to say here is he was very, very visionary, and he was very convinced that these kinds of things would take place. And he set a challenge for humanity, if you will. I mean, if you think about this, this is the grandest list of challenges that we should accept for the growth and development of the human species and for life on Earth, to represent life on Earth through our galaxy and bring it to a wider, hopefully, consciousness if we run into some other beings with self-awareness. Here's a mock-up on the left of Ziacosi Spacecraft. This is all definitely the area for fuel, and then so sort of living areas and working areas, and then of course the command center of the spacecraft. Now Ziacosi not only just sort of said oh, I think that they'll build space suits and then go outside of the spacecraft and work. No, he said to himself, how would you do that? And he actually wrote down a set of procedures. Now, if you know anything about NASA and space flight, it's everything you do. You don't sneeze unless you look up a set of procedures in a book that somebody's put together. Not only put that set of procedures together, but then tested them, proved them, refined them, and then you can sneeze. Right? And then that's the way it works with space flight. So here we are as early as the 1920s, and Zio Koski has then put together a recipe for how do you actually do a spacewalk. Okay, so you might be in Earth orbit, and so you're in free fall around the Earth, and that means that you feel weightless. And so you pressurize your airlock here, and then you open your airlock because it's at the same pressure inside the spacecraft, and then you climb into it, and then you lock your door here, you depressurize, and then you open up to space and go out and do your business. And then when you get done, you come back in. And interestingly, the Soviets in 1961, I believe it was, somewhere between 1961 and 63 or 4, I can't remember exactly what year it was, they did their first spacewalk. Alexei Leonov was the first person to walk in space. And they used this precise recipe as we show here from Ziacosi. So the rocket scientists in Russia had definitely read Ziacoski's work. The only difference was that this chamber was a soft pressurized expandable structure that they pressurized in it, and then it stuck out of the spacecraft rather than using valuable space inside the craft. Many of his imaginings and inventions have become, again, science fact as technology has developed. This is sort of the inside of one of Ziacoski's spacecraft. And you might even notice if you watch Arthur C. Clarke's 2001, the spacecraft that flies out to Jupiter has a round area, working area, and that's, I think, also been influenced by Ziacosi. Here's the inside of the Space Lab satellite, I don't want to say space station, from 1975, showing that, in fact, a lot of this structure is very similar to the way that Ziacosi had envisioned it. All right, so now we're going to move to Robert Goddard. And the thing about Robert Goddard is that he really was sort of an engineer physicist, and he actually was interested in building the rockets, okay? Now, he lived in parallel with Ziacosi, but he had never read a single word of Ziacosi. So this is a situation where isolated people are thinking about the same things around the same period of time, which is another thing that happens in humanity. It's like these ideas sort of bubble into the consciousness and with isolated people. And then sometimes the right people catch those ideas and push them forward, even working alone. He was extremely isolationist. And one of the reasons that he was isolationist was that he wrote an article talking about using rockets to go to the moon. The New York Times flayed him in an op-ed, and he was so ridiculed and so embarrassed by that, I think this is around 1919, that he just said, I am done publicizing this work. I'm done with anybody knowing about what my dreams are, what I'm doing, and I'm just going to do it on my own. And so he basically disappeared from the radar, if you will, from that point on. Up to that point, he'd been a math professor and physics professor at an engineering professor at Clarkson University, I think it's in New York. And so he realized something similar to what Ziacosi realized, and that is that he realized that using liquid propellant was the best way to get a rocket to accelerate with the greatest efficiency. And Ziacosi had written this down, But not only did Goddard write it down for himself, but then he actually built a device that used liquid propellants. So he is known as building the first liquid propellant rocket. Now, I think everybody's heard about the Wright brothers and their first flight at Kitty Hawk on the beach in North Carolina in 1903. That's another thing that's, you know, pretty household common knowledge or taught about in school at some point in time. Little known is this little farm in Auburn, to most people, in Massachusetts, which is where Goddard flew his first liquid propelled rocket in 1926. And this turns out to be his aunt's farm. And you can see a picture of his rocket here as a semi-colorized photo. And I think it flew 40 feet in the air for 2 seconds and reached 60 miles per hour. And that, ladies and gentlemen, was the first liquid rocket flight. Obviously, a long way to go, but you know, proof of concept, baby steps, one day at a time, working hard, one day at a time. The comparison for the Wright brothers was that their flight lasted 12 seconds and it went 120 feet. Now, rockets are a lot more technically challenging. So the thing that's, I guess I want to say here is that the Wright brothers was in 1903, and then by the middle of the 20th century, we had commercial aviation flying all over the planet. And then the same thing with rocketry in 1926, and then by 1969, we were flying humans to the moon. So as people do these things, I can imagine there are other people looking on it. That's really a quaint and cute toy that you built there, Robert. But that's not what he's thinking. He is thinking, let's build this and send people to the moon. And those are the dreamers and the doers that change the world. Now, some of you may know this, but New Mexico has a very rich history. And for those who might be watching this that don't know that we're at New Mexico State University. And so New Mexico is very dear to our heart in the southern part of the state, where we have the White Sands Missile Range, and we have the some Air Force bases. Holloman Air Force Base, also near White Sands. And then over in Roswell, there were some areas where there was some military flight development going on. Not only that, but El Paso, just south of us, has Fort Bliss. And we're going to find out that that played a large role in rocketry as well. So this area of New Mexico is very rich in space history. And if you get a chance to go to the Space History Museum in Alamogordo, you should definitely do so. And then you might also realize that Spaceport America is 70 miles north of New Mexico State University. And this is where Richard Branson is currently doing test flights to send humans into space on his spacecraft too. Okay, that may actually happen in 2021, I hope. So Goddard left the East Coast, went to New Mexico, particularly Roswell, and started building rockets. And it turned out that Charles Lindbergh, who was famous for flying solo across the Atlantic, had become very famous and very wealthy, and he was able to help Goddard get a grant from Guggenheim, and that really funded a lot of the rocket science that Goddard was able to do. Now, he worked alone, as I said, and that probably really slowed his progress down considerably, rather than working in large groups with other like-minded people who would infuse fertile ideas into the process. Okay, the US government didn't pay a whole lot of attention to him, but what we're going to find out is the military did finally become quite interested in the rocket. Now, there is a movie later I'm going to have you watch called Spaceflight, and in it this quote is brought forth, but this is one of Goddard's famous quotes, and I just want you to understand that as Goddard was working, he worked hard every day because he was chasing his own mortality. He had this dream and he wanted to get as far along that path, knowing he would never get to the end of that path. And in fact, the way he saw it, there is no end to this path. So I want to read this quote, it's spectacular. How many more years I shall be able to work on the problem, I do not know. I hope, as long as I live, there can be no thought of finishing, for aiming at the stars, both literally and figuratively, is a problem to occupy generations, so that no matter how much progress one makes, there is always the thrill of just beginning. Now, unfortunately, Goddard's life was cut short by throat cancer in 1945, and it's too bad because the United States had just won World War II and brought over Werner Von Braun and all of his rocket scientists. He lived just long enough to open up and look inside one of Werner Von Braun's rockets, but never really got to work with Werner Von Braun. And I always wondered what it would be like if Goddard and Von Braun had had 15 years of being able to work together. So what we're going to find out is the German military took a much stronger stance about rocketry for reasons that we'll talk about in the next lecture. But I just want to show you something about the rocket clubs that existed in Germany. So it wasn't like an isolated person. These are clubs of enthusiasts. The person who started these clubs, or the main club called the VFR, was this gentleman, Herman Oberth, lived from 1894 to 1989, a very long life into his 90s. And I want to remember that, this is a time before rocketry. And he read Jules Verne, and then he actually lived through the Apollo program, saw humans walk on the moon, lived through the space shuttle program, saw that entire reusable technology, and then died before the International Space Station was really able to take hold. He also did see the Challenger accidents, where we'll talk about, which is was the biggest space disaster up to that point in time. Now, Herman Oberth was a Prussian, which is to say he grew up in a very militaristic society. And, you were meant to be strong, and you were meant to be intellectual and tough. And I think you can see that in these photographs of this young man, that this was instilled even at an early age. You can see this missile man stare coming out of this young boy, which never left him his whole life, as you can see from all of these photos. And I think that says a great deal about his drive and personality. And he wanted to get a PhD in physics. And so he wrote, but he liked rocketry. And so he wrote this PhD dissertation on rocketry and rockets. Now, he basically kind of, in a sense, also reinvented all of the things that Ziacosi had talked about, because remember, Ziacoski's Russian works really didn't come across in the early part of the 20th century into the other countries. So it turned out that when Oberth defended his PhD in front of his committee of eminent scientist mentors, they denied his graduation because they felt that what he had written wasn't physics. And so he never did get his PhD, so you can't call him Dr. Oberth, but he did publish his dissertation. And I'm showing a picture of that publication here. And it turns out he was married to a fairly wealthy wife, and she supported the publication of the book. And it turned out that it became a very popular technical book in Germany and spread across most of Germany. And in fact, made its way back to Prussia as well, where there was another young person by the name of Werner Von Braun, who opened that book and saw all the math in it and said, I better take some math classes. And so that's what happened with Werner Von Braun, so that he could learn how to speak the language inside of Herman Oberth's book and learn to build rockets. So again, you can see that Herman Oberth had great dreams in mind. One day they can be so powerful, they could be capable of carrying a man aloft. So this was really the motive behind these rocket pioneers. Their motives weren't to build weapons. Their motives were to build the ships that will take people to places, to destinations. One of the things that happened was that he had been commissioned by a movie producer to build a rocket so that they could film its launch for this movie called Frau de Mond, the woman in the moon. And it turned out that he wasn't able to deliver in time for the production. And so basically all the scenes in that movie of the rocket launching are, models and whatnot and special effects. But here's an image from the movie showing the rocket getting ready to launch and then having landed on the moon, which apparently doesn't require a spacesuit, according to the Germans who made the movie. They maybe should have worked talking to a few scientific consultations beforehand. Now, one thing I want to mention about this rocket in the movie is that it's a staging rocket. Okay, so it launches, and then, as you all know, the lower stage burns its fuel out, and you jettison it. And we see that today with Elon Musk's rocket, then where he actually brings those back to Earth and reuses them. SpaceX does, but in the old days, they just discarded it and let it burn up in the atmosphere and sink to the bottom of the ocean. And then the next rocket on the upper stage fires, and the rocket accelerates more. And this was mathematically developed by Oberth. Here is his drawing in his book showing you various stages of the rocket. And he really invented the multi-stage rocket and worked out the mathematics for it. And so as you can see, if you go back to Zio Koski's rocket equation, what happens is you're all of a sudden lightening you're making your mass much smaller very quickly. You slowly are burning the fuel away, and then you take the thing that was holding all that fuel and get rid of it. So now your rocket is a lot lighter. So when your next booster fires, you accelerate much more rapidly and get more velocity. So it's a very efficient method. And so this is basically a diagram of that. Before you had staging, you just had your single rocket and you carried all of this empty mass as you burnt your fuel. But now if you empty this mass, you get rid of fuel. You also discard the extra mass that was holding that fuel, and you fire your upper stage and off you go at a much more rapid rate. It was really great that the people in the movie had talked to Oberth enough that they had written into the movie a staged launch. First time ever on film. Okay, this is a very famous picture on the left of this rocket group that was started by Oberth. This yellow circle here is showing Oberth. And I'm not going to try to pronounce that. My German is not good. But they call themselves the VFR, and this was really developing in the 1930s, which, if you know your history about Germany, this is when Hitler was beginning to take power. He took power in 1933, and then World War II started in 1939. So it was during this period of time that the Nazis were taking control and consolidating their power in Germany, that this rocket club was building these more and more powerful rockets. And the military got very interested, okay? But before all that happened, a young man by the name of Werner Von Braun, who I told you about, saw Oberth's PhD dissertation, learned the math to read it. By the time he was 17, 18 years old, he decided that he needed to go actually to Germany and work with Oberth and join the VFR. And so with no announcement whatsoever, no letter written ahead of time, he just got on a train, packed his bags, and went out there and knocked on the door and said, "I'm here to work with you folks." And they took him in, and he turned out to be an extremely talented young engineer and rocket scientist. And so this is a picture of young Werner von Braun having joined the group. And you can see the level of rocketry by the time he was just turning 20. You can see the level of rocketry that this group had come to build. And they used to basically have sort of circus affairs, as they called them, where they would they would publicize a rocket launch. They would go out in a field. They would charge an entrance fee for people to watch it from a safe distance, and then they would fire off the rocket. And they used that money then to fund the building of more powerful rockets. Eventually, after World War II, Werner von Braun was brought over to the United States, as well as Herman Oberth, and you can see them here with the US Army on their rocket science team. And we're going to be talking about this a great deal in the next lecture. Now, science fiction, science fact. Sometimes you want to go back and honor, in science fiction, you want to honor those who were pioneers of, in your past that made your vision possible. And so Gene Roddenberry, the creator of Star Trek, honored Goddard and honored Oberth by making a ship called the USS Goddard. Now, this would have been in the Star Trek The Next Generation that they expanded all of Starfleet in the storyline and had these other ships. And so this is the USS Goddard. And again, and you'll notice here, it says that it's a Korolov class type of ship. So it's the name of the ship, Goddard, the class of the ship is Korolov. Now, at the beginning of these slides, I said there were two famous rocket scientists, Werner Von Braun, whom I mentioned here, and Sergey Korolov. That's the Korolov class we're talking about here. So it's named after the Russian scientist, rocket scientist, Sergey Korolov. And I'm not talking about him in this slide deck, but I will be talking about him in the coming slide deck a great deal, because he was a mover and a shaker and a hardcore human being. That's all you'll when you hear his story. And then Oberth had a class of starships named after him as well, each having individual names, of course, but they were more scout types, whereas the Goddard was a deep exploring type. So just for fun, I thought I would show that. Right. So then I wanted to say the spacecraft payload contains Herman Oberth's PhD dissertation. Now, the thing about science fiction becoming science fact interwoven into this lecture here is shown here with the cover of Time magazine, 1949, 1959, and then 1969. Now, from 1949, no rocket had ever put a satellite up in space. Basically, by 1949, we had only had the V2 rocket that had reached space. That was Werner von Braun's Vengeance weapon number 2. And but then you had all this space science fiction, showing robots on the moon, for example, in this case, one of the moons of Saturn. And then by 1959, we had actually sent up the first satellites. In 57, the Soviet Union put up Sputnik, and in 1958, in January, the United States put up Explorer 1, and we had our first satellites. So you can see here this idea of satellites, and then this concept of actually photographing the moon. And you will find out that in the early 60s, the Soviet Union actually flew a spacecraft around and took photos of the sorry, it's not Pink Floyd, not the dark side of the moon. They took photos of the far side of the moon, because the moon has one face stuck toward Earth at all time. It's called being tidally locked. And so as the Earth orbits, it always has its face facing the Earth. It's locked in this configuration. So we can never see from Earth the far side of the moon. And then that was the first time. So this is being shown as a possibility here. And then in 1969, we put humans on the moon. So you can see here in a short 20 years how rapidly breakthrough technology, engineering, and basically an industrial system was mobilized countrywide to push forward this quest to have humans reach a true destination outside the Earth. Zio Koski died in 35 before this magazine was even put out, 15 years or so before. He never really saw a working rocket. Goddard's rockets never reached the edge of space, but they went very, very high, and he became very prolific at making solid and reliable liquid fuel rockets. Von Braun died in 77, so he clearly saw humans walk on the moon, and he was a key component. Without Von Braun, we probably would not have accomplished that in that period of time. He also died before the space shuttle first launch, which was in 1981. The government kind of put him out to pasture in the late 70s, and he didn't survive much longer after that. Oberth, he lived, as we saw, till 1989. He saw the entire space race as well, saw the end of the space race, and then he also saw the space shuttle fly for at least 8 years. And finally, I'd like to end this slide deck with science fiction made science fact. I want you to make sure you watch those 2 videos. They're very, very important for understanding this arch that humanity has made in terms of rocket and space dreams to rocket and space reality, okay? These dreams are still today existing. It's just that the people are reaching further than they used to reach in the past. Of course, unless you're Zio Koski, where you are reaching out into the entire galaxy. But for those who are a little uninitiated on what they're looking at here, this is the Saturn V rocket, and this is what we call the moon rocket that actually launched the astronauts to the moon. And you can see there is a very large exit velocity of your gas here, and then you're losing mass with time. And so following Ziacoski's rocket equation, the speed is picking up on the rocket. And here we have, I think this is Apollo 16, probably John Young. I can tell that it's the commander because they have red stripes on the suits, and that happened after the Apollo 14 that they started having the commander wear red stripes on the suits. And also, this is the rover, which has a high gain antenna back to Earth, so you can tell that Earth is up, back, and behind us. And this was allowed them to drive. You can see the tire marks going off into the back here. And this allowed the astronauts to travel up to about 3 miles away from where they landed in their lunar landing module. So that really opened up moon exploration. Here is one of the early space shuttles on the launch pad. Here is a classic space shuttle launch, as you can see, and we'll be talking a great deal about the space shuttle. And then one of the things that happened in the era of the 80s was that people began to work outside the spacecraft and actually do functional work, repairing space satellites and then relaunching them out into space. Hubble Space Telescope, for example, was repaired up to 4 times, and it really saved that telescope. That was launched in '93, and is on its 29th cycle now of doing science, where each cycle is a year. So almost 30 years of Hubble Space Telescope, and that telescope had multiple problems and would have died if the space shuttle was not able to go up there, capture it, and then have the astronauts go outside and repair it and then send it back out into orbit. So that brings us to the end of today's lecture that, again, I would like to sort of say is called Science Fiction, that begets science pioneers and rocket pioneers. So when we move into the next segment, lecture 2B, we're going to talk about what's called Cold War rocketry. And we're going to move briefly, quickly remind ourselves of what happened to the world in World War I and World War II, because that sets up what happens with rockets ever after from World War II, and is basically chapter 1 of the space race, okay? Which the space race is considered to have dawned or started on October 4th of 1957, when Sputnik was launched by Sergey Korolov of the Soviet Union. And then some people say that it ended when Neil Armstrong put his foot on the moon. But other people say it ended in 1975 when the Soviets and the Americans actually flew a joint mission and docked together in space and shook hands in Earth orbit. So it's not clear really which one is right, but I like the idea of shaking hands in space as really marking the end of the space race era. Okay, so I hope you enjoyed this lecture. I want you to watch those 2 supplementary videos. And don't forget that we are now beginning reading of the Space Race book. And there are 2 assignments there for reading 2 of those small chapters that are key to understanding what we're going to be talking about in the next 2 or 3 lectures. So definitely need to read those. Okay, so we'll see you guys next time.